Things are going well for you. Where's the music? Carlicone, we're finally on weak derivatives in PDEs. Why isn't the chat box working? Oh, good. Okay. What? Why isn't... Sorry, Let me test... Okay, Shimmerbot is still working. Why isn't this chat working, though? That works. Huh. Overlay. Save and copy overlay URL. Ooh, wait, where do I do this? I do it here? Why are you not working? Sorry, I'll look at chat again in a second. I have no clue why the chat box isn't working. That's so annoying. Yeah, I guess it's just gonna be broken. Let me see what's up with chat. Distribution derivative? I guess so. And hey, Leo, competitor in my starting soon stream animation. Are you streaming on Twitch too, or just YouTube, Leo? Because I actually can shout you out more. I need to do a better job of stuff like that. Just YouTube? Okay, okay. I still should be shouting you out more. Competitor in your starting soon stream animation? I don't know what that means. Okay. Sakuna saying, want to give you a poem that expresses my feelings about the state of the world. Also, hey Rex, keep true to the dreams of your youth. Ooh, that's a fun one. Hey Lucas, hey Boz. The real chat box is the friends we made along the way. Maybe. Sorry, I'm trying to both read chat and think of a way that I can make the chat box work, at least temporarily. I'm coming to blank though. Wait, all I have to do is hit refresh. Bruh, okay. Well, problem solved. Okay, let's read the poem that Sakuna posted. I'm just gonna read the English part. That's the first mention that shows true. Water in the hand, the worst work of God, one sun today, another tomorrow. That it not cry the bell, if not double for the two. Life that is Spanish cards by the luck. Never want a day of more, and no one died never ever. Now before one's death, glory to the conquistador, this final conquest, to rob your name from the list, from the life and the love. I can talk now, I'm really bad with poetry, and it's even worse to read it on stream. when it's hard for me to focus on any one thing. So I gotta say, I don't understand it. I'm sorry. How you're feeling about things these days? How they come up with the gamma function? That's a good question, Lucas. Let me think about that. Classic debugging strat, yeah. Be live at like 4:30. Depends on the juicy nap you really want to take. Well, what's your time zone? Or like how many hours away is that? I'm sorry to hear that suck now. I hope that things turn around for you. And Viv, hello. I'm doing all right. How about you? I'm in the home stretch of my master's degree program, just like a few more weeks until I graduate. Wonderful. That's wonderful to hear. Family's doing good too? With care and understanding, your life will have no obstacles. Ooh. Doing some research work on what? Less than an hour. Oh, okay. I'm gonna be a master, yep. Okay, so Lucas, how did we come up with the gamma function? So first, let me say what the gamma function is. So if I were to graph just the horizontal axis n, the vertical axis is n factorial, only worrying about natural numbers. Let me put tick marks actually, because those are important for this. 2, 3, 4. 1, 2, 4, 5, 6. Zach, thank you so much for the raid. I was lurking on you. I hope your stream was fun. I'm a little bit all over the place today, so forgive me if I'm not very focused, but I'm alright, Desson. I kind of fell asleep late last night, but just what happens. But yeah, Zach, thank you so much again. Right now we're talking about the gamma function. Lucas asked just kind of how did we come up with it, and so I'm starting just explaining like what it is, and then I'm gonna look at the Wikipedia page probably to figure out like how it started. Let me see what Viv just chatted before that raid came in, so I don't lose it. You did a survey to find out what percent of Americans can add up to 100. Only 33% are capable of doing it. That means 77% of Americans can't. True. That's a very good survey, Viv. And so once we're done with this question about the gamma function, in my PDEs class, we're on to weak derivatives and weak solutions to PDEs. So that's going to be what the homework stuff is about. It starts with one thing. I gave Colorcone VIP because he's been just incredibly helpful, and I appreciate how like just enthusiastic he is about just talking about math. So yeah. EDKLs come up with once you have exponential, you know, integration by parts, it's pretty natural to come up with. Yeah. You don't know how we should have blue mod in this chat. I don't. For YouTube chat, it usually has a lot of trolls. I feel like I haven't needed mods for YouTube in a while though. It's been a while since I've been trolled. I mean, you know, that would certainly help. But yeah, I mean, helping with my homework is not a prerequisite. But Colorcone has definitely been super helpful with my homework too. Oh, see, and Leo's offering you VIP in his chat. Although I don't think YouTube has VIP. Okay, so sorry, I'm not doing a very good job of explaining this. So first off, with the factorial function, I think you already know this, Lucas, but if I were to just graph it discretely, it would look like this, where we only worry about natural numbers. The gamma function is what's called an interpolation of the factorial function. So it basically means it connects these dots in kind of like a smooth way that makes sense for some definition of sense. Like there's many different ways that you could, but this is the kind of, it's the one that comes up the most naturally. Um, it's like a series. I don't know what you mean like a series. Or I don't think series do that necessarily, Lucas. Like connect the dots for functions. Maybe there's a way that I'm just not thinking of. Hey, energy. You're like a series. It's true. Yeah, sure. I'm working on a question from Lucas right now, but you can be right after if you'd like, energy. There are general translation inputs are only. Oh, I guess that could be a series. It could also be a sequence. You could say that like you could talk about the sequence of like we could talk about n factorial as a sequence of numbers. And the gamma function basically takes you from these natural number inputs to any real number input. Well, not any real number, almost any real number input. All right, enjoy your nap, Leo. To reflect on the argument against the axiom of choice based on sets which are not measurable, like the Vitali set, or paradox like but not Tarski paradox. I only know the very basics of that energy. My understanding is that you can take it or not take it, and you're actually kind of fine either way. You just need to know what the consequences are and be willing to deal with them. But as far as I know, it's fine to use it, and it's also fine to not use it. You have a video saying that Tarsky is like, who cares, but you're still sleeping. Leo, I guess, saw it. Okay, and so the gamma function, it comes up. I never really encountered the gamma function until I learned about asymptotics. So it can sometimes come up organically if you're trying to get approximate solutions to differential equations, basically. Yeah, that is kind of an interesting question, Colorcon. What, like, how unique is it? It's definitely the most natural one, but it's not the only one. But you can say that about any interpolation. Asymptotics, it's basically it doesn't have to be just this, but the simplest way I can think to explain it is it's getting an approximate solution to a differential equation using power series, but there's an asterisk on power series. It's like it's a more general version of power series. Instead of x to the n, you could have like e to the minus x squared x to the n or something like that. But it's basically, it comes up in like when we need to make approximations for just like complicated functions in general. And often differential equations provide those complicated functions that we want to approximate. So that's where I've encountered it personally, but let me see, like, when was it, like, why was it created? Hey, Phobos, I saw you doing art earlier. It went well. You don't believe the axiom choice should be accepted because I believe mathematical objects should be measurable. That's my personal philosophical intuition. Cohen proved it's independent of the Zermelo-Frankel axioms. Yeah, I don't know enough about it. I think your average mathematician probably doesn't care that much, to be honest. Like or they like your average mathematician nowadays at least isn't much of a philosopher. Functional equation plus analytic seems like a good start. Wikipedia said it's not enough. We did an art. Oh, nice. Don't you also see it in complex? I mean, it's often brought into complex analysis because it's a good example of like a function with poles. I don't know that it comes up organically. Or at least when in my complex analysis, I don't think it came up organically. It was kind of shoehorned in. Okay, and so Carl is saying the organic way that it came up comes up in there. Ooh, it's kind of interesting. Why? But okay, this is saying what they were doing, but why were they doing it? Yeah, I've used Stirling's formula for one of my homework problems last quarter. Yeah, Lucas, I don't know that the gamma function was created for a specific application. I think it was just Euler being the curious dude that he is, and asking how you can extend factorials to any number is just a natural question to ask for someone who's doing math research. I'm not sure they had a specific application in mind for it. You just want to learn how they came with the definition. Oh, okay. So that's like a fun exercise. Like why it works. It's just an integration by parts, actually. Here we go. This is what I want. Okay, so the reason why this formula works, let's calculate, let's calculate gamma of 3. Well, yeah, okay, gamma of 3. And it works for complex numbers too. I just want to worry about real numbers for now. And then I always get the order mixed up. Gamma and okay, it's equal to 3 minus 1 factorial, which is just 2. So we expect to get 2 with whatever integration we do up here. So let's try it out. Gamma of 3 is equal to 0 to infinity t to the 3 minus 1, which is 2, e to the minus t dt. I believe the functional equation for zeta is organic. Okay, and so this is just integration by parts here. So this lends itself well to the kind of table method of integration by parts too. So I'm going to do the table. So we want to take the derivative of t squared. We want to integrate e to the minus t. So 2t, 2, 0, I forgot how far we need to go. Minus e to the minus t, e to the minus t, minus e to the minus t. Then we do plus, minus, plus. So we get t squared e to the minus t minus 2t e to the minus t. Oh, but there's already a minus, so that turns into plus. And then, wait, plus, minus, plus. Wait, no, I'm getting my things mixed up. That's a minus. That's a minus. This is all minus? Oh yeah, that makes sense. 2e to the minus t. And these are all evaluated from 0 to infinity. I think it's more natural from the zeta function rather than from the integral definition or being derived from the zeta function. Oh, okay. You know what I'm doing? Okay, well, you know what integration by parts is, right? This is a trick to do it quickly. Maybe I shouldn't have used it, though. It's slightly loud? Okay, thank you for telling me. You know, honestly, I'm not even feeling this song anyway. Oh, Femlux is, though, so I'll leave it. Damn you, Dessen. Okay, so I'll do it more slowly. So for integration by parts, the way that I like to set it up, wait, do you know integration by parts? I'm just realizing you might not know integration by parts. Oh, shoot, sorry. Yeah. Okay. I need, I need to explain to you integration by parts then. Um, okay. Let's back way the heck up. Hey, it's RPG. Nice. Good luck with your electrical engineering studies. A and B, you figure out what those are, like undetermined coefficients? I think maybe think of something else. So integration by parts is something you use when you have the product of two functions. Oh, partial fractions, yeah. So we don't need that. Hey, Aditya. And it comes from, if we're trying to integrate the product of two functions, we can think about the product rule for derivatives and use that as a basis to like figure out how to integrate the product of two functions, because we do know how to take the derivative. So this is the product rule for derivatives. No, it's RPG. I'm a master's student. Yeah, UV VDU thing. So if you do know that, I'll stop explaining this. And I can actually write out like just what the result is. It's like I'm taking u equal to t squared, dv equal to e to the minus t. Okay. So then du is 2t, v is minus e to the minus t. Thank you, it's RPG. They called me old. It's okay, I am old. So we do uv minus v du. So it becomes minus t squared e to the minus t minus, but then there's a minus here, so it turns plus. Oops, I already forgot it. From 0 to infinity. 0 to infinity, 2t e to the minus t dt. I'm from America. I'm in Washington State. Okay, and then this is another integration by parts. And so rather than doing this integration by parts over and over again, there's this like, it's called the DI method or the table method that just kind of lets you skip past this. And so without showing all the steps from here on, this is the result that you'll get if you do integration by parts a second time. I mean, it would be more aesthetic, but I think I'd be wrong. You have your linear algebra final this Monday? Good luck, Art. For MIT, it is expensive, yeah. Okay, and so now we need to plug in these limits. So the nice thing about the exponentials is e to the minus infinity. The limit as t goes to infinity of e to the minus t is 0. That's just a good fact to know. Exactly, yeah. And so I don't even care that there's a t squared here or a t here. We could use L'Hopital's to actually prove it. But exponential decay is so much stronger than a polynomial, like it's going to be 0. So it's going to be 0 minus 0 minus 0 for everything involving infinity. And then minus, now with 0, we will get something different. Well, this first thing is still 0. This one is 0. But this one is not 0. 2 times e to the 0 is 1, so it's just a 2. And look at that. We have a minus minus 2, so that's just positive 2. That's the answer that we were expecting. So that's how you use the definition of the gamma function. Yeah, exactly. And so the reason why this works is actually because of the power rule. So if you have a t squared here, or let's just say like a higher net number so it's more clear. If you have a t to the 5th and you keep taking derivatives, you get 5 times t to the 4th, you get 5 times 4 t to the 3rd, 5 times 4 times 3 t to the 2, and so on. Like, you're getting 5 factorial out here by the time you take all of these derivatives. You're not using Taylor series directly, but they are the formula for a Taylor series has the same exact it has that factorial for the same reason. So the formula for a Taylor series is fn x naught over n factorial x minus x naught to the n. That n factorial is there for the same exact reason as this. So it's not because of Taylor series, but they both, like, it's for the same reason as this power rule thing. But the reason why the gamma function is kind of, in a sense, more powerful than the factorial function is that if I add t to the, like, I don't know, 9 over 2, like a fraction, I can still do the same exercise. I'm not going to, like, the powers of t won't go away entirely, but that's okay. I don't know how the integration by parts is going to work, but it's still, like, because of the power rule, you'll get what 9 over 2 factorial would be if that was defined. Which, I'm in applied math. You know, if you're ready to be studying for like 2 weeks straight, is that normal? That's a very normal feeling, Art. If you've been studying for 2 weeks straight, I think you'll be okay. Your professors greater than renowned universities? 100%, Desson. Gamma function used for drawing half integrals and half derivatives? Oh, maybe. I don't know very much about them. See, I guess, does that answer your question about the gamma function, Lucas? A little? Okay. Yeah, Max. This isn't quite the way that I wanted to write it, but you can definitely take the factorial of a rational number. I guess even irrational numbers too. But this format of writing it, I'm not in love with. I've done it before where I just kind of like write it out explicitly with like you do like 9 over 2 times 7 over 2 dot dot dot. I forget what the stopping point is. I think you stop when you get less than 1. But then you also have divided by something else. I don't remember at all. Okay. Sounds good, Lucas. Thank you for the question. Okay, if anyone else has a question they want to ask me, please feel free. If not, I'm going to work on homework. Resume this by talking to math students rather than doing it only from school or online. Yeah, it's a good skill to be able to read like math textbooks and learn from them, but it's often difficult to do that too, or like it's not like the quickest way of learning something. Your caffeine intake has been in the positive arithmetic progression since last month working in the internship. Yeah, working will do that. It's the Flowster. How's it going? Wait, explain things so bad. Yeah, it's like they always start off with the hardest part, with like deriving it, and that's usually not all that helpful to understanding why it's important or what it actually means. Your attention span maxing? Do you have like 5 different tabs open right now? Because I definitely have done that. Attention span minning. Okay, okay. You have any goal in it? The end of my Algebra 2 class. You learned M-adic topology. Never heard of that. What the hell? Perfectoid spaces? Then do a bunch of integration by parts to compute weak derivatives. Reading some books? Noise, noise. Okay, so the first part is to prove the weak derivative is unique if it exists. Electrical engineering and quantum mechanics, I know very little about either of those. I like I really enjoy learning about E&M and physics. I don't think I would enjoy electrical engineering as much. Quantum mechanics would be cool to learn someday, but as of now I haven't studied it at all. iAdic sounds like an Apple product for junkies. You should see in masochism. You can definitely have some really painful problems in E&M. But the book that made me really like it is Purcell and Morin's E&M book, and I just like self-studied it, and I didn't do... I only did a few of the painful problems. I mostly avoided it and just like learned about the concepts. And it's so freaking beautiful. It's such a cool topic. So, hey, you want to go to the bathroom every 30 minutes? You should stop drinking water. Let's read Griffiths. Let me see, like... I still want to read the last few chapters of Purcell and Morin, because I never have done that still. But what does Griffiths cover? I don't think I'd want to rehash stuff, but Griffiths, I think, is probably a bigger book. Probably does more. You don't do math anymore? Oh. BDSM? No, that's the Lebesgue, or no, that's the dominated convergence theorem, in my opinion. That's the kinky sounding math thing. Ooh. That could be fun. Images. I remember learning about images in Purcell and Morin's book. That's for I forget. Maybe for calculating electrostatic potential. It's like a trick. Multipole expansion would be good to learn about. We barely did dielectrics. All of this would be cool. Wow, chapter 7 is Ohm's Law? That's a long time to wait. Oh, the pointing vector? One of the funniest names for a vector. Okay, yeah, I mean, I think there's a lot of cool stuff to do in Griffiths. There's so many books that I would want to read, though. It's hard to like choose one. It's RPG. This is, I mean, what's on the screen right now that I just pulled up is homework from my partial differential equations class. But I'm also learning about mathematical modeling of cancer and calculus of variations. You be down to sell our souls and learn all 6-figure skills like machine learning, SQL, or AI. No. Machine learning would be cool to learn about for its own sake, but I don't want to apply it in the military. Okay, so if we want to prove uniqueness, the typical start to proofs like this um, is... Wait. Well, what would the other thing be? Remember math had a bunch of nerds who math is Greek to you? Yeah. Ugh. A weak derivative. Uh, it's an inner product that behaves just like the inner product. Or okay, if you want to understand the derivative of a function, but you can't compute it for some reason, um, you can find the inner. You can find. You can take the inner product of the derivative of u with a test function, and find that it behaves exactly like the inner product of something that is well defined. Which is basically like this statement here. The thing that we don't understand is the d alpha u. But the thing we can understand is this, because phi is C infinity. It's RPG, yeah, I guess unless you're doing number theory. Then it's still about numbers. It only has one digit. That, yeah, Jed. I I'm really not enjoying this class. Fluffy, I think so, yeah. Um, it's some compactly supported C infinity function. If it's defined, I guess omega could be Rn. Okay. Riemann Stieltjes, I forget what that is. The integral? Wait, what is this thing? I don't know why there's weights in that picture. Hey, Rudra, I don't know what PFI means, but hello? I don't know what's going on with Riemann Stieltjes. I don't know if it's the same thing, maybe? Hmm. I'm confused how to make this not like um yeah, like I don't know what to modify in this definition to like I was almost I was initially gonna say like a fee one and a fee two, such that like fee one is not equal to fee two, but this is true for all fee. So like what the hell? Like what is there to make that's possibly not unique? Finish studying physics, wanted to scroll on YouTube, found your shorts live. Yeah, this is some this is related to partial differential equations, Rudra. It's and it's like a graduate level class, so it's not easy. I wouldn't feel bad for not knowing it. Also, things related to set theory. I mean, we're talking about like Hilbert spaces too, which is more advanced set theory, I guess. Join college. Oh, nice. Good luck, Rudra. Yeah, energy. It's I only know the bare basics of Hilbert or Hilbert spaces. I think it's like linear algebra if you have infinitely many dimensions. Like it's a very poor way of describing it, but not completely inaccurate. But yes, I mean I mentioned set theory because that's in the background of a lot of things. So function represent unique up to almost everywhere. You can use the fundamental limit of calculus of variations. Like an exterior derivative, I wouldn't know. Fundamental limit of calculus of variations. Uh, as in like you would want to subtract this over to the other side. I still don't really know what we're showing is unique. But yeah, I don't know what the other candidate is supposed to look like though. Take a partial derivative. Oh, Floppy, it's because my professor is really sloppy with his notation. It's just the alpha first partial derivative. Like this is talking about the order. He's really careless with his notation. But like Uh, yeah, and if you point stuff like that out to him, he says that you should just infer what he means. And he refuses to fix it. So it's just kind of a waste of time. I said fuck you. Just walk up to him and say that. Fluffy says fuck you. But like, what about this is different? Like, would the U change into a V? Would the phi change into a psi or what? Like, that's what I'm confused about. Like, what actually changes? Can I ask some questions related to magnetic moment, angular momentum? Oh, I probably wouldn't be able to help with those anyway, Rudra. Um, I'm not that good with that stuff, so my physics is pretty basic. No, Millennium problems are not easy. Alpha in the computation exercise, it's multi-index notation. Um, alpha is a vector. So if you say alpha is equal to like 1, 5, 3, why not? Then d alpha is the first order derivative for x1 composed with the fifth order derivative for x2 composed with the third order derivative for x3. And if you have just d1, then that's basically your gradient. Like, not as a vector, just the number 1. Hold a couple Millennium Problems, you hold until they go up a little bit? Yeah. None of the above? Okay, yeah, Clark, that's what I'm confused. Like, I want to take the difference of two things and show the difference is 0, but I don't know what the two things should be. That's why I'm confused. Like, that's why I don't know what is unique about this, or like what alternative could there possibly be? And also, D2 is the Hessian matrix. Usually, we don't even use the more general notation. Let's say G is the weak derivative of U. You have int G of X, V of X. So like this? Like, I guess maybe like independently this equals that, but also this equals that. No minus 1. Oh, wait. Really? Like this is equal to this original thing? Okay. So you were saying before about the fundamental lemma of calculus of variations. I mean, I probably want to do it with this though, don't I? I was using like this. I'm not in Caltech, no. Shouldn't the derivative be shown as unique? I don't know. This question is confusing to me. Okay, but this is the thing we want to integrate by parts on a bunch of times. So we can get it so it's just phi. And we know that how do we say this though for generalized d alpha? So I can see how the integration by parts, like, because of the compact support of phi, all the boundary terms will always be 0. But the issue is that we're going to kind of run out of derivatives asymmetrically. Um, like if alpha is equal to, I don't know, like 362. Once we integrate by parts twice, we're going to run out of like derivatives of x3. We don't have the right quantity? Okay, well, I'm sorry, Color Cone. I have no idea what you want me to do anymore. It's probably a useful thing to have for this problem, though. Making the integration by parts. We know what we should get. Oh, hey, here we go. Okay, this... This helping answer my fundamental confusion of what the hell does uniqueness actually mean here. Okay. So I needed to not think about the integral definition at first. Um... UD alpha... VDX... equal to -1 alpha... V VDX. Oh, V1. Okay, this is the setup that we want then. And it's what color code was trying to get me to understand with the G equals H thing. And color code, I'm sorry that I'm not like following what you're saying. I just... I'm always very confused with everything in this class. Okay, well that is a really short proof. Once you set it up right. Actually, we can just divide out the -1 to the alpha, can't we? Okay, so V1 equals V2. Fundamental theorem of calculus variations. Uniqueness identity theorem? Maybe I couldn't tell you. It's a trauma of organic chemistry? I don't know why you would. Okay, how do we compute the weak derivative of that bad boy? Daily study time? I never timed that. I don't know why so many people seem to time it. Or to guess like 4 to 6 hours. I really don't think that's something that's worth measuring or really caring about, though. Nourish by parts party time. So it has to be true for all phi. So can we choose a particular phi that's somehow convenient? Is that how we do this? What am I doing here? Let me, okay, we actually kind of did this in the or in class. How do we set this up? Wait, omega is the real number line. Zero, 2x, and 0. We vibe the integration by parts. This is like a homework assignment. It's RPG. Vibe these nuts. Very true, Vasan. Hope you're doing well. This is 0. The thing 1 for x more than 1? No, it's a constant function. Do we want to... What do we want to do? We're missing the one part. Well, so what we did in class is we had the example problem. U of x equals... You're going to do this backwards. 0 for x less than 0. X 0 less than x less than 1. 1 for x greater than 1 is the weak solution. To the differential equation, y prime of x equals 1. That's an x less than 1. 0 otherwise. And we set up an integral that looks just like that, basically. I'm trying to figure out how my work isn't very clean here. Oh, okay. I know what I did. I'm going to leave the right side alone. The left side will split up into two different integrals. X squared. 1 to infinity. Here's just 1. Now what? We integrate by parts to get rid of the phi primes, apparently? Okay, this feels redundant. What advice for me, because I'm going on a school camp and I'm scared? I mean, I don't know what the school camp is going to be about, but just have an open mind and just try to have fun. Like, new experiences are always, like, scary, but it's what keeps life exciting. You see what I'm doing? I'm glad, because I don't see what I'm doing. I'm just blindly fumbling my way through this problem. Thank you, Dessen. I do try sometimes. Oh wait, this is just freaking fundamental theorem calculus. Why am I trying to integrate that by parts? Or know the solution looks like? I guess so. UV minus VDU. V of infinity is 0. Nice. Okay. That'll work out. Hey, Slim. I would. If you were a worm, I would still love you. Yeah, if. Okay, so we get a minus phi of 1. The 0 term is just 0. Plus 0 to 1, this thing. Plus phi of 1. So the phi of 1's cancel. And I guess we get the result that we expected. So what is the weak derivative again? Is it the weak derivative is this? Like, this is the answer I would actually say? I still don't understand weak derivatives, but okay, we'll move on. Okay, if you map 0, 1 to R as a discontinuous function. Ooh, why is the domain 0, 1? You need weak derivatives because um it's way, way, way easier to find a weak solution to a PDE than it is to find a classical solution to a PDE. And the only trade-off a weak derivative gives you is instead of giving you the exact value of a solution to a PDE at a point, it gives you like an average of the solution in a small neighborhood of the point. And for applications, that's pretty much always good enough. Morton de la Pau? Probably saying that wrong. Thank you for the follow. Or Mort and? I don't know. So what if I assume we can just take a specific example here. Like that? I'll just say more unless you tell me otherwise. Sounds good. Welcome in. If you want to ask a question, please do. Otherwise, this is me kind of working on my homework. Yeah. Welcome in. Great philosophy of approximation once again. Yeah. I assume a jump discontinuity is enough. It's an open domain though, so they might want us to have a divert like get like a 1 over x in there or something. I don't know though. Well, what would we say? I guess the derivative's gonna have an issue at 1/2. Or like the integral. There's like a direct delta thing that's happening here. But shouldn't direct delta be fine? Yeah. But like I thought this thing, the part of the point of this is that it's not broken by direct delta functions. Like it'll not be a function. Okay. Oh hey, okay, and the book does another example with this. So here's a jump discontinuity. Okay, well, let's start with this first line and see if we can... Well, actually, no, let me read this line too. We're using... Okay, the example up there. I'll use my example, though. Wait, phi prime. Uh, is it just v phi? Yeah. Okay, and then... Okay, color cone. Yeah, I'm used to these problem statements being sloppy. The fun part is that if we're sloppy on the test, he just marks off all the points for the entire problem. So he doesn't... He dropped another gem in class yesterday, which is that he tries to never give partial credit. From 0 to 1/2 contributes nothing. The Dirichlet function would still have a weak derivative. What a handsome man! It's one way you can say it. How do we think about this? The Dirichlet function would still have a weak derivative. Yeah. Like, I guess they're saying there's not a weak derivative function. It's a weak derivative distribution, I guess. Because it's 0 almost everywhere. Okay, yeah. So the right-hand side should be 0 almost everywhere. I never mentioned it to anyone, Dessen. I have joined Discord servers for my classes using my streaming account, so they could theoretically see my Discord status. I've never had anyone bring it up to me, though, and I've not brought it up to anyone. Nourish doesn't care about what happened on the null set? Well, even if it's like a direct delta type of thing? Talking about the Dirichlet function. Oh! Wait. Oh, sorry, yeah, you were talking about the Dirichlet function. Yes. Thank you for... I saw like a capital D and I was like, oh, Dirac. But no, Dirichlet. Even DIR. And so you're saying, like, even the Dirichlet function that would have uncountably infinitely many direct delta functions. Like, would still be fine with this? Or it would still work as, like, a counterexample? The weak derivatives would be 0. Okay. Yeah, I just want to... I, like... In my mind, if we're thinking about delta functions, like, wouldn't the integral come out to be equal to phi of 1/2? Dirichlet is 0 almost every weak derivatives cannot see difference between the 0 function. Okay. Should somebody in my school know who I am from Other non-Twitch math streams? Oh, okay. What does the book do? When you have a jump like in your example, you cannot remove the jump by changing your function on a null set. I have not done functional analysis, no. I wish I had. Nope, no measure theory either. I also wish I had done measure theory before this class. Oh, that's what you're saying, color cone. So, I mean, could I simplify the Dirichlet example and um can I just say this? Like it's zero almost everywhere except at 1/2. This is Evan's PDE book. Classic grad class experience. Yep. Wait, do I want it to be almost, or do I want it to be zero almost everywhere? I don't know what I want anymore. That's the sloppiness in the question. Okay. I think that whatever this textbook example is doing is what the answer to the question should be, if that helps you. Because I'm still not sure that I understand exactly what the sloppiness is that you're saying, but I kind of... I understand, like, the basis of what you're saying, like, the difference should be being zero almost everywhere. In my example, is not zero almost everywhere. I don't understand why that makes a difference, but I can go with it. Why is this final line a contradiction? Is because, does that, well, okay, it's a rearrangement. We know minus this integral here is equal to this thing here. And then they chose a particular phi. They rearranged, like, each side here. Make the function goes bad on some null set. Everything would still be fine. Weak derivatives don't see the difference in your function if you modify a null set. Function go bad on some null set. Everything would still be fine. Maybe it doesn't? Like, I think that's the point of the question. Like, the weak derivative is not capturing differences that happen on null sets or something like that. So if I want a counterexample for this question, color cone, I do want my original counterexample. The sloppiness is that, like, this is not a good counterexample. Okay. Okay. Hmm. I'm still trying to figure out what the contradiction is that the book is claiming. Oh, 1 equals 0. That's... Oh. Okay. Yeah, okay. 1 equals 0. Okay, that's a pretty good contradiction. Yeah, so I know why the direct distribution isn't a function, because you're not, infinity isn't a number. I know you can represent it as the limit of functions that go to infinity at one point. Or like, you know, or like you can use like a Gaussian or what do you call it, like a box function or whatever. But like the direct distribution is not a function itself. Hmm. In terms of test functions. Uh, can I? By the distribution is not represented by a function in terms of test functions. That's probably what we talked about when we did, when, or I like we probably like talked about this or something like this when I was on your stream. Oops. Um, function is when symbolic radius are 0 outside of some slightly bigger radius. Tattoo test function. Right, that's what the book is doing in their example. Your stream is already ogre. It's all like a 50-minute stream? Doesn't even have to be concentrated at 0. I I still don't really know what I'm doing. Check out the beginning and see if I want in. Um, so this thing is 1. This thing is 0. Oh my god. I need limits also. Ugh. God, this freaking class is confusing. Okay, so this thing is 0. This thing is 0 because of this limit setup that we have, but then this thing is 1. I guess. I don't really know what this means, but I think it works. Alright, let's pull in another problem. Weak-ass derivative. It's beaten up by the other stronger derivatives. This is just part 1. Shit, let's bring in both parts. Weak-ass derivative. And yeah, what is the derivative of ass? Two AS? Yeah. Something I do the dishes. Is that when you have all your realizations? Oh god, part 3. Dude, one of our homework problems like a few homeworks ago was derive the finite elements method. And that was basically all the help he gave you. Ugh. Consider the very simple ODE, minus y double prime of x equals x squared. Okay, we can definitely solve that ODE. Yeah, let me see it. Like it didn't actually say finite elements method. He just described the finite elements method without telling you the name of it. Wait, that's not it. Yeah, here it is. It's problem 5 here. Like, this is such little scaffolding for... like, this is the simplest version of finite elements you can possibly have, but, like, it's just such a ridiculous question. Like, this is very little help for how complex the question is. Stop trying to have to write code. Hey, Yanis. Hey, Syntax. You think this is a sick question, Color Cone? I hated this question. And even like when you do finite elements this simply, you just get the finite difference method, which is way easier to derive. Ugh. You always learn something new in linear algebra. Didn't know the Jordan form is similar to its transpose. I didn't know that either. You should probably sleep your bachelor thesis. It's too much fun. Well, what is it on? I'm glad to hear that you're having fun with it. I'm told the pain by doing Hartshorn exercises. Oh god. Okay, what is the function that when you take the derivative twice, you get x squared? X to the fourth divided by 4 times 3 with a negative sign in... Wait, yeah. Minus 1/12 x to the... Oh, wait. Ooh. Oh, this is sines and cosines. I didn't look at the boundary conditions. That's funny, color code. Basic K-theory of triangulated categories. That sounds fancy. I don't know anything about that, but I'm glad that you're enjoying it. Okay, so C1 cosine x plus C2 sine x. And then if we're doing this the undetermined coefficients way, do we need to guess? Hey, Harrodson. Oh, it's been a minute. I remember you though. Do we need to go like 1 degree more? Like, do we go x cubed or just x squared? No, same degree. Okay. It was full of crap. That happens. That's part of math. You improved? Nice, nice. These are solved exercises, only hard because the little we know about it? Okay. You write in chat the full pentagonal word is called axiom for the triangulated category. And I have 3 different sources just saying this follows by the Yoneda lemma, still trying to figure out how exactly. Oh, that must be frustrating. How do we determine all these coefficients again? Mixed wheel theory? I don't think I'm gonna understand that, Harrison. I'm sorry. I that I just I don't think that's the type of thing I'm gonna get. So, an introduction to abstract algebra. This book is like 300 pages, split into 2 courses. I think the first is to like page 200. Self-setting, it's cool and all, but holy, this is much for one course. Good luck. I studied a little bit of abstract algebra. It wasn't for me though. Hey, K3 Rails, welcome in. Oh shit, I forgot to do this last time we had a first time chatter, but whenever I see a new person chatting, I do like to let them know this math niche exists on Twitch. It's not just me. There's a whole list of people that I can like recommend in case you're interested in this sort of thing in general. You read a book on derived category that had a section on triangulated category that refused to state the axioms. Bruh. Hey, Skirt. Everything has been figured out except how to live. Okay. Geometry of parallel lines. Oh, okay. Oh, cool, cool. Zach is awesome. Page 98, now exam on the 17th. So like a week or two should be doable, but still. Wait, you're self-studying, but you still have an exam? What does that mean? Oh, twist memes. Hey. It's going good. How about you? Okay, why do I click on anything category theory? Sure. Cofiber sequences. Oh, that's what it... Okay, okay. Oh, this is how undetermined coefficients works. The diagram looks like... Oh, I didn't even look at the diagram. Oh, hey, yeah, it does. People are up to steal. Oh, I see the ping of wonders has come through. Yeah, I could play as soon as like an hour. I can type that in the Discord too. Not enough time to get the pickles ready. Oh god. K3 Rails. Oh yeah, so like what I'm looking at right now is just an ODs thing. I'm a master's student taking a partial a PDEs class, and I'm not enjoying this class so far. I thought I would like PDEs, but so far I have not. So some things I've learned I've enjoyed. but overall it's really difficult. Heat equation? It's a good equation though. I don't know chemistry, especially not physical chemistry. You might be able to try actual education though. He might be able to help you. He stream. I don't know if he'll be streaming today, but he does stream on YouTube. Do ODs for first class next semester. Excited as hell. Oh, he's taking a week off? Okay. Yeah, hello world. I'm not sure then. I would be surprised. Usually ODEs is not a very fun class, I'm going to be honest. They usually, most universities don't do a good job of teaching ODEs, I think. Yeah, Destin, that is a big change of tabs. Thank you for the follow, K3 Rails. Sorry guys, I'm just trying to catch up with chat and then I'll get back to working on this problem. Training categories are kind of meh anyway. Apparently my instructor said one should instead work with some infinity categories, more canonical. You know anything about that? I think if you're motivated to work on a problem, that's like the most valuable thing. It's better to work on a problem you like than a problem you don't like. OD's not bad. You found it easier than Calc 3. I agree with that, yeah. It's just like ODs is just, they make you memorize a lot of stuff, and I'm not a fan of that. Might I be down for an OO category study group? I don't even know what that is. I don't really want to study categories though. You have the book does, hopefully. Okay, so this is the particular solution, and we plug it back into the ODE. Just the particular solution, and then you match coefficients. Okay, it's clearly has been a minute since I've done undetermined coefficients. No, thank God. I did not have to memorize the Laplace transforms. That would be terrible. Second derivative of that bad boy. Well, don't B and C fail to be determined? I guess the boundary conditions might... We can't have a linear term. Well... I assume B and C are going to be 0. But if we plug this back into the ODE... we get this. So doesn't A equal 0 also? Something about this feels so wrong. Wait, can't I... Okay, wait. Back up. Oh, wait, no, it's not sines and cosines. Oh my... Dude, oh my God. My brain is so fried. Why don't I just do this? Just integrate each side. What am I doing? Okay, there we go. Any good problem heavy math books for topics related to high school math? For JEE, I don't know. JEE is a unique beast that I know very little about other than the problems are stupidly difficult. There's gonna be a lot of YouTube channels that talk about it, but I don't know personally. I'm sorry. And hey, Jeremy B. So I'm still working on it. I'll graduate in a few weeks, but it's a master's in applied math. And like I guess like when you say describe it, I'm not sure what you mean, but like the courses I've taken are like complex analysis, scientified computing, 2/4, mathematical biology, 3/4, asymptotic analysis, in partial differential equations, and calculus of variations. These first 3 classes are the core classes that everyone has to do, and everything else were electives. Yeah, if you have a specific question, let me know. But that's like stuff that I've been studying. There's a whole sequence of classes on stochastic processes and probability that I'm kind of bummed I missed out on, but there just wasn't enough room for it in my schedule. Like geometry behind ODEs, as it turns out, it's further studied. Decided not to go that route. I don't think I know much about the geometry of ODEs. Don't fear the JE, fear the JE advanced. Yeah, Phobos, that's true. The regular JE I can do. I don't really want to do them, but I can. JE advanced I definitely can't do. Hardcore high school math, isn't AOPS a good reference? Oh, it could be, yeah. You got baited believing an April Fool's video about 3 hypotheses being proved. Oh no, Egbert. Harrison, I don't know. I don't know why I called you Egbert then. Said complex analysis is easier than real analysis. That really depends on the professor. There can, if I were to just like gamble on it and put money down on something, I would guess, well, no. Okay, if we're comparing a first semester real analysis class to a first semester complex analysis class, like complex analysis usually just cites, like it builds on real analysis. You wouldn't want to study complex analysis before real analysis. I think undergrad, or I mean I was trying to make this undergrad. To be fair, I'd never taken complex analysis or real analysis at the undergrad level. Well, I sort of have taken real analysis at the undergrad level. Those are the courses that I've taken, Jeremy. But usually for complex analysis, like you skip over a lot of the fundamental proofs in complex analysis because they just mirror the proofs for real analysis. So in that sense, like complex analysis kind of has to be harder than real analysis, but you also do get to skip over that crappy stuff. So it's kind of a catch. It kind of depends on your definition of easy, because you don't have to deal with the annoying epsilon delta proofs usually. I think in your average complex analysis class, but you do have to understand them. My favorite complex analysis book, I've only read one, which is Abelitz and Focus, and it's fine. I haven't read any other complex analysis book in depth. Is the YouTube stream doing okay? I think it's doing okay. Okay, let's get these. Let's get A and B. Y of 0 is 0, means B is 0. Y of 1 is 0, minus 1/12 plus A is 1/12. Okay, that is like the longest I've taken to solve an ODE. That's way longer than it should have taken me for me to solve that. Now we try to emulate the idea of a weak solution. A weak solution would mean that for all phi in C infinity with compact support in the interval 0, 1, we have this. You like this problem 3? Okay. And so the actual problem statement, I guess now we're down at 2. Verify your closed form solution of the ODE has that property. So y prime... Actually, it's easier if I take it from up here, isn't it? A third x cubed plus a 12th. So we want to verify the interval 0 to 1 of u the prime x dx, right? Is this a typo? Should this not be y prime? Like, these shouldn't both be primes, right? Uh... I'm fairly confident that's a typo and it should be just y. Let me look in the class Discord. What if someone's already posted about this? Nope. Okay, so I'm gonna guess there's yet another typo in this homework assignment. That looks like an exponent, and it sure isn't. Let me write down the original thing. P prime. Yeah, Harrison, I think what the stuff you're doing is way beyond me. I don't think I'm gonna understand it. Someone else might take a look at it and want to talk about it, but like, I know nothing about the type of math that you're doing. I guess, okay, I guess you put the minus sign in the ODE. Just to eat the minus sign that would pop out in the weak derivative formula. Okay, and I guess we're gonna integrate this by parts. Actually, it might be y prime. I think it is y prime. Why is it y prime though? Because it's a second order ODE? Huh. Okay. Maybe I was wrong to assume that's a typo. I don't know why it should be y prime. other than it makes the math work. Yeah, that is fair, Harrodson, but I see things like, I mean, look at it again, like dual numbers in wheel theory, and I just know that I'm gonna be lost. It's gonna take me forever to figure out even the most basic part of what it's saying, and I kind of need to get this homework done. So I just don't want to spend the time on doing that. I'm sorry. 12p 0 to 1 0 to 1 x squared phi dx, and this thing is 0 because of how phi is defined, so we get the equality that we want. I think that's all we need for problem 2. Like, okay, Harrison, I'll skim it right now. But like, yeah, I'm sorry. I really, I just don't want to, like, it's just gonna take me way too long to figure this out. Like, I'm sorry. Destin, if you want to interpret it like that, you go fucking read the messages in Discord and you talk to Harrison about it. I'm sorry, Harrison. I really wish I could. I just, if you had a simpler question, I would do it. But like that, it's just beyond me. Geometry Dash. I don't know how I would know that. I'm sorry. I hope you did well, but I can't answer that for you. Take 10 of your favorite functions that are infinitely differential and compactly supported. Let us call them T1 to T10. Make an ansatz. I recognize your name, Geometry Dash. How am I supposed to know how you did on the test for an algebra, on an algebra test? Yeah, that's fair, Harrison. And like, I genuinely, I really wish that I could just like read that and say something smart about it, but like, I'm struggling to keep up with my current work, and I just only have so much brain power to think each day, and I just really can't spend the time right now to figure out the stuff that you're working on. If it was something that was more in my wheelhouse, I would love to engage with you on it, but I just, like I said, I just only have so much energy to think each day. Thank you for understanding. Um, arrive at a 10 by 10. Linear system. Oh, is this hinting at finite element method? I assume we don't need to actually name 10 functions here. Geometry Dash, this is for a class I'm taking on partial differential equations. And we're specifically talking about what are called weak solutions, which are kind of like approximate solutions to partial differential equations, in a way. I'm only just learning about them, so I have a hard time describing them. I have a hard time describing what they actually are because I don't understand it for myself yet. Yeah, this is a very difficult class. It's like a graduate level class on partial differential equations. There's a lot of really deep things that we have to learn here. So do I want to integrate by parts the left-hand side? Like, do I want to do a fundamental lemma of calculus of variations thing? Am I close solving? I guess it depends on your definition of close. I've done the first two parts of this one problem. But the third part is kind of the entire point of the question. The first two parts are kind of easy, so... Okay, let's try and integrate by parts on the left-hand side and just see what we get. Yeah, I'll figure it out eventually, or I'll get help from the TA. Worst case. We want to integrate TI. TI prime. I double prime dx. V is equal to TI. I don't think this is helpful because y double prime is equal to minus x squared. So this just feels like a tautology. Um, hmm. 10 by 10 linear system of equations. Hmm. I don't know what they want here. Let me look at a previous homework where we did have to do that finite elements thing. Because this feels like it's basically, it's another finite elements question. Hmm. I don't know. I think I want to think about this one more off stream because I've been stuck on this one for a little while now, so we should just get a different one. Oop. Okay, so what is B again? I don't think it's Banach. It's a bilinear form on a Hilbert space. That's what B is. I mean, I guess the problem statement did say that. I could have just read it more thoroughly. Also, there's a part 1 for this problem, but not a part 2 apparently. Like, there's a 1, but there's never a 2. This is the entire problem 4. There exists an A in Rm by n such that B of xy is equal to the inner product of x, a, y. How do we do this? So we know that, so we're holding x fixed. So it's linear in y. Um, B, x, y. Wait, didn't we do this in class? I'm looking at my notebook right now, and it seems like we did this exact thing in class. Um, oh wait, no, this is a different thing. We were defining B of xy such that it's equal to this. This thing for a general bilinear form. Can you always express a bilinear form like this? I have no clue. Can we? Hey, Aeneas. Where do they talk about bilinear forms in the book? So I have given some homework problems to ChatGPT just kind of for fun to see how it does, and it does get some of them right. It sometimes makes some really stupid mistakes too. It doesn't do that bad though, from what I can tell. And it's gotten a lot better than what it was, and it's only going to get better, I think, as they keep improving it. Does Appendix D describe? Yep. Okay. Okay. Um. I'm not saying bilinear forms exactly, just linear. Ugh. Let me just Google bilinear form. What comes up? Studying Minecraft, I use a program called Journal++. Hmm. Dang it, Wikipedia has failed me. Don't ask me, I don't know shit. I don't know shit either, it's okay. Exists an A and Rn by n such that b of xy is equal to x ay. Hmm. I have no clue. You can start with 4, I guess. What's number 5? That's my gut feeling too, Aeneas. Like, I feel like you can't just leave X alone. Like, that seems problematic. I have no clue how to actually do anything, though, with it. Every F in a Hilbert space gives rise to a U in the Hilbert space, such that BUV is equal to FV. Sure. This should be true. So we know that BUV, since it satisfies the Lax-Milgram theorem, well, I guess the statement is, it's given in the statement. Alpha U V is bounded above by that. Let's just worry about the bound from above. And we know from Cauchy-Schwarz, this is bounded above by something. Not nothing. Cauchy-Schwarz inequality. Right. The magnitude of U square, magnitude U, magnitude V. That's what I was thinking of. There's no way it's this simple though, right? Oops, that's not a U, that's an F. Okay, wait, no, yeah, it's not this simple. Okay. So, and then, okay. I don't know how many times I need to say okay. Let me put this over here. We know that BUV is equal to the inner product of FV. This still feels like it's way too simple. Like, this is way too easy. And I feel like I'm missing something. Oh yeah, okay, the issue is this inequality goes the wrong way, right? I can't just use this. Would it work for the bound from below? This might be one of those ones where, like, one of the bounds is easy, the other bound is difficult. Oh. The bound from below is only valid for the same element twice. It's not ideal. So we can't use it for BUV. Could we use it with... Could we be fancy, though? Could we consider, like, U minus V? Or even U plus V, I don't know. And do some triangle inequality type of thing. Maybe we'll stick with minus. Well, the triangle inequality, the reverse triangle inequality is what we want, right? The one that forces these two things to cancel every time. I don't know if that's helpful though. There is another inequality we might be able to use though. I was thinking of this one, but that's actually not what I want. Wait, is it what I want? Not really. Uh, maybe it is what I want. ChatGPT told me it's true, so the answer has got to be false. I don't disagree. Um, Cauchy's inequality. Ooh, does that give us a nice cancellation? Because we do have... Well, I don't think that actually tells us. So what I was going to say is Cauchy's inequality tells us this plus this squared is greater than or equal to 2 UV. And that would cancel that 2 UV. But having this thing be greater than 0 isn't telling us much, I don't think. So maybe let's back up. Oh shoot, I actually shouldn't be streaming for much longer. We do... I was going to apply this to this. The more I look at it though, the more I don't think that's going to be helpful, because this V isn't the same as this V. Or like, not necessarily. And like this F wouldn't be the same. Like whatever F I get from applying it here is not the same as that F. This feels like something you can do just by playing around with these inequalities and just trying to find the right combination of doing something like that. I don't know if I've found it here. What is coercivity? Uh... I think coercivity is this property here. When you have a bilinear form that's bounded from below. I'm trying to find where yeah, it is that. And if you want to explain what that means, I would have a hard time doing that. I still have the bilinear form page up, Aeneas. Bilinear forms correspond precisely to elements in Rn star, which has dimension n squared. Let's see if I can find that again. Oh, what menace defines that as the transpose? Oh my god. Lowercase t and it comes before the thing? That is disgusting. 4 should be true. Huh, okay. I still need to find that. I want to say in some sense, since a x to y to xay is injective in dimension and Rn is n squared. That's this first thing. Oh, well, that's a general universal property. I don't know. The elements of Rn. Okay. Thank you for mentioning that, Aeneas. I think I do need to wrap the stream up here, though. Okay. And on the bright side, I did get half this homework done. Like, I did the first 2 problems entirely. And I did the first, like, half-ish of the 3rd problem. So that's, like, exactly half. So the entire thing is 5 problems. So that's something. Yeah, I think that's got to be it for me, though. I need to take a rest. So, anyone who's here on YouTube, Sunny Minecraft, or anyone who's lurking, thank you. I didn't stream much this week. Hopefully I'll stream more next week, but no promises. So, goodbye, YouTube.